Hello everyone. Let us see the construction of Epicycloid by using a software called AutoCAD. I'll show you the construction and related calculations and what is the difference between conventional and by using a software. What is the difference? We'll try to see. Before I'll start construction, let us take a simple problem to understand. Okay. What is Epicycloid? Let us see Epicycloid by using AutoCAD, which is a 2D drafting tool. Alright, now here we can save the time by using software. We can save the time and we can draw accurate sketches without any errors. For example, in conventional representations, there might be a problem with drawing instruments or the person who is drafting it. They'll try to avoid errors like 0.1 mm, 0.2 mm, 0.01 mm or 1 degree. Okay, such things we can eliminate here. We can take exactly, you can't truncate the number. For example, if you want to measure a distance of 12.25, which is not possible uh, conventionally, they will try to, you know, take the route, will try to round off and take that particular number, will truncate the number. Okay. Whereas in this case, we can directly take 12.25 only and dividing the line when it is in decimals. For example, if I say 150.23 is not possible with a scale which we use. There again you go with dividing a line into number of segments by considering any acute angle. The construction procedure becomes very lengthy. So here we can avoid such things. Okay. So what is an epicycloid? Let us see. Epicycloid is something where a curve is traced. Okay, for example, these are the two curves. Let us take. Epicycloid is something, a curve is traced with respect to a reference point P when it rolls up to a distance of its circumference. Okay, when it rolls upon another circle in this direction, this particular reference point will make multiple markings or instances on its way till the end point. When you join all the points, that is going to give us the epicycloidal curve. Let us see this construction by using a software called AutoCAD. And what is this angle? How to calculate this angle? All these things we'll try to sort it out. For this case or for this session, let us take small d is equal to 50 mm and capital D, which is a directing circle, which is equal to, let us take some 90 mm. And how to calculate theta by considering these two values, how to calculate angle theta, that is more important. Now let us see the formula. This I'm calling it a small r, this let us take it as capital R or capital D, and this is a generating circle which will generate the epicycloidal curve, and this we call it as directing circle. Okay, this discussion we already had when I have explained you about the conventional representation or how to draw it on a sheet of paper. Okay, the formula is, it is the circumferential distance or length of the rolling circle is equal to length of arc. Alright, now what is the circumference of a circle? It is 2 pi r, that is equal to, now the distance or the angle it is going to take is theta out of 360 degrees. Okay, only theta we are going to consider, followed by the generating circle and the this 2 pi r, sorry, 2 pi r of the generating circle, 2 pi r of the generating circle. Here this is the generating circle radius, circumference 2 pi r, and here it is the directing circle circumference 2 pi capital R, small r. Okay, then these two will get cancelled. Accordingly, theta is equal to 360 multiplied by small r by capital R. This will go down. Okay, this is the formula. All right. So by considering this formula, if you will take 360 multiplied by 25 divided by 90, so it is 45, going to be how much? 200 degrees. Theta is going to be 200 degrees. Now by considering this 200 and 50, 90 as generating and directing circle radius, let us construct the epicycloid by using AutoCAD tool. Now let me draw a line. For drawing a line directly, I can pick it from the sketch tools, or else I'll say L enter in the command prompt. It is asking me specify the first point. I specify the first point. Accordingly, I can draw a straight horizontal. I can draw a straight line. Okay. From here, the epicycloidal curve will travel, or else if you want a proper elevation, symmetrical elevation, then what you can do, you can split the 200 into two halves. That particular 200 into two halves. That is also one of the possibility. So here I'll turn off the ortho. You can start here either, or you can split it into two halves. Okay. So overall angle is 200 degrees. If it is 200, then I'll just draw a line of some length followed by infinite distance I have drawn. Then I'll draw a circle, C enter, at this point of radius 45. Then I just try to move this circle. I'll try to place it somewhere. M enter, move F8 to turn off the ortho. Okay. Let me check the dimensions again by using a dimension tool. 90 overall. Yes, correct. Okay. Then what I do? Let us consider this circle. Then again I'll try to redraw the line. L enter. I'll start from the center up to some infinite distance. F8 to turn on the ortho. Then the line becomes straight. This is the directing circle over which generating circle will travel. Accordingly, it will trace the curve with respect to the reference point P. Alright, now what I do here, let me rotate this particular line to 200 up to 200 degrees angle. To rotate, RO is the command, enter, select the line, enter, select the point. Now I can catch hold of that particular line with the help of a cursor. I can rotate. But what is the angle you're supposed to rotate? Now if I'm rotating this horizontal in a clockwise direction, then you are supposed to give minus 200 as the angle, followed by should copy the existing line. Okay, I'm taking a copy of this horizontal and rotating it to an angle of 200 in a clockwise direction. If it is a clockwise direction, minus negative symbol is important. Alright, this is how it is going to be. Now unwanted TR, double enter, I don't need this curve. This is how it is going to be. Followed by, let me draw the generating circle, C enter, C enter, then I place somewhere, or else at the end point. You can place wherever you want, because ultimately I'm going to move that circle. 25 is the radius. Then I would like to move this circle to this intersection. Select M, enter to move. Hold the tangential point and zoom out, place it with this intersection. Okay, then remove unwanted. TR double enter to trim this line, this horizontal, and even this horizontal also. Okay, and even this is also not required, but let it be. Okay, now this circle will roll upon the directing circle. Alright, now let us divide the circle into some 12 or 8 segments. For that, I'll take again a line, command L enter, and zoom out. Here, I'll just try to draw. I'll take the cursor onto the circumference of circle. I'll get the line. Let me change the color of this line. Let me change the color to green or blue or any other. Okay, only thing is, just to make you understand, select, then I'll say ARR, nothing but array. I want to do polar array with respect to the center. I want some 8 copies. Okay, this is it. Okay, now accordingly you have to name it. Okay, as this is the reference point, let me write a text here, enter, and here height would be some 2, enter, 0 angle, yes, close this one. Then I'll say P. Okay, I'll just try to use this P, Control C, Control V. This is the reference point, and this is point number 1. This is point number 1. This is point number 2, point number 3, 4, 5, 6, and 7. Okay, so this is a reference point P. I am considering in a counterclockwise direction. I would like to take the count. Okay, P. So text edit. Text edit is a command to edit this P to 1, this to 2, 3, 4. I'm trying to edit the text which I have already pasted. 6, 7. Okay, now this P acts as 8 again. Alright, now at every instance I would like to draw the curve. Then what I'll try to do, I'll select this curve, I'll say O, enter. I want to offset this particular curve. Right click, they have 3 options, through, erase, and layer. I want to take the curve through this particular point 1, zoom and check it out, intersection, then select through this point, then again select. I'm still in the command called offset. Select, again select this one. All right, now wait a minute. All right, once I offset this, okay, now generally what we'll try to do when you draw it on a sheet, you'll try to take the extension of it till it go meet the 7th point. I'll take EX, double enter, extension till the next. This is not required, this is till the next. Okay, this is how it goes. Now 6, 2 intersections fall on same curve, 5, 3 fall on same, 7, 1 fall on the same curve. This is what it means. Again, now try to remember, when you draw cycloidal curve, there won't be two curves. The center curve or a center line and the line passing through 6, 2 will collide. Okay, will coincident. That is the reason you have only one single straight line there. But here, if you could see, uh, uh, curve is passing through center C. Let me name this Control C. Let me place it here, and let me edit the text. This I call it as C. Alright, center. Now center curve is different, and this particular curve which is passing to 6, 2 is different. So intersection should be on that. Now let me divide the center curve, and let me change the color and show you. Change the color. Okay, let me divide the center curve into number of segments, as many number as we have divided the circle. Also select div, division is, or divide is the tool available. Select the curve and say, as you have divided the circle into 8, divide the curve also into 8 parts. Okay, it got divided. P type is activated, that is the reason you got all the points. Now this is, let me take this C, I'll copy, and this is C1. I'll take a copy of it. C1, this is C2, this is C3, this is C4, C5, C6, similarly 7 and 8. I just try to edit. I'll try to edit this now. Text edit. I'll try to edit this to C8, C7, C6, C5, C4, C3, C2, okay. Likewise, notations are taking enough time. C1. Alright, so what is our discussion? The circle, when the circle start rotating from with respect to this reference point, the reference point will make number of instances or intersections. That we'll try to see now. When the circle changes its position or changes its center from C to C1, what happens? Select the circle, move, enter, and hold the midpoint of the circle. Then I say place it at the C1. Okay, place it at C1. Now intersection of this curve and the C1 curve, or first intersection curve. Intersection of these two, here you are supposed to give a point, PO, enter. Let me place a point at the intersection. Okay, let me change the color of the point also. Alright, when it changes its position from C1 to, okay, text edit, this I supposed to make C1. Again, select circle, move, it changes position from C1 to C2. The intersection of circle and this curve, this is the point you are supposed to consider. Okay, again let me change the color. Likewise, the circle will travel throughout the circumference. M enter, changing position from here to here. PO enter, and intersection of those two, this one, C3 and the circle. Similarly, select the circle, M enter, hold the midpoint, place it at C4, again PO enter, and this is going to make a point here. Again select the circle, M enter. Repeatedly I'm doing the same procedure. Okay, and here now have a look. The same circle is intersecting with these two curves. Again, this is already done. Okay, to the left side of C4, if you could see here, already a point is placed between the intersection of circle and the curve. Now you are supposed to take a point to the other side, to the right side, where these two intersections. Similarly, when the circle changes its position, circle M enter changes its position from C5 to C6. PO, intersection of circle and the curve, here is the point. Next, circle when it moves from C6 to C7, intersection of circle and the curve C7 is this one. Alright. Next, when the same circle moves from C7 to C8, if you look at it, is exactly touching this point. Okay, so end point of the circumferential distance. This is how it is making number of instances. I'm taking back the circle to its original position. Okay, so all the instances, let me change the color of all the instances so that, oh, I made a wrong pick, it seems. Yeah, the pick was wrong here. Okay, this will come down, I supposed to. This is wrong, I made a wrong selection. This is wrong, this is supposed to be upon the next curve. Okay, I'll take circle, move with respect to the center. I'll try to place a sixth point at 6. Intersection of circle and this curve, that point is important. PO enter, here is the point. Again circle, move, enter, center, 7th point. Okay, intersection of these two. Okay, PO enter, here is the point. Alright, again I'm moving back, M enter, taking the circle back to its original position or the starting position, starting point. Let me select all the points or instances which I got through the movement of the circle. Okay, let me color them all as red. All these red color intersections are the points traced by the curve. When I join all of them, like we have a command called spline command. Now it is starting at this point 1. This is the first pick, second, third, fourth. Where when you draw conventionally on a sheet of paper, you'll try to join them all with a free hand. Alright, here I just try to zoom out and see. Let me, yeah. Let me change the color of the curve, then I will see. Okay, or else let me change some other color, maybe to yellow. Yeah, this is the curve. Let me redraw this curve. TR, double enter. I'm trying to draw the curve again. SPL is the command starting at this point 1, 2, 3. This is the fourth point, fifth point, 7, 8, and 9. This is how the curve is going to be. Have a look. This is ultimate requirement. This is called an epicycloid. I'll try to change the thickness. Thickness can't be kept, it seems. Let me change the color to yellow so that you could see the sketch properly. TR, double enter. This is not required. So this is how you construct an epicycloid. Okay, epicycloid is the curve traced by a point on the circumference of the circle when it rotates and reaches a distance of its circumference. Okay, and at every instance you're supposed to give, let me take this P, Control C, Control V, and wherever you got this instance, I name it as P1. Okay, similarly this has P2 and this has P3. Okay, accordingly I'll try to place all the points. Then I edit, text edit this one as P1. Alright, accordingly I'll place all the points. This is the final requirement. I'll try to zoom and place it something like this. Now this is how it look like when it comes to a drawing sheet. Okay, this yellow color line, and that will take a print. Okay, in case of a soft copy. Okay, I hope you understood. The advantage is like you can avoid even a 0.1 error and 1 degree of angle also. Accordingly, in the same curve you can place as many number of dimensions as you want. Dimensions can also be placed. For example, if I'll take diameter of this circle is this much. Okay, that you could see properly. Diameter 50. Similarly, I can take this arc radius also. Have a look. It is 90. So whatever we did, whether it is right or wrong, that decision you can easily make. And you have many other angular dimensions can also be given from here to this point. Okay, only this thing I am reading. So in between also you can read. Alright, this is how it look like. Further, if you have any doubts, you can ask me. Any clarification you need, you can ask me through your comments. Okay, thank you.